So hi everyone, we're going to do the last part on permutations, and it's going to be permutations of duplicate items. And what do we mean by duplicate items? Well, suppose we have the word Mississippi, and as you all know, it's M-I-S-S-I-S-S-I-P-P-I, and so there are lots of letters that repeat. In fact, there are 4 I's, 4 S's, 2 P's, and 1 M. And it turns out that's really important. If you wanted to ask yourself how many words could you spell where a word was, let's say it's a 4-letter word, and a word could just be any 4 letters in a row. Well then, for instance, you could spell the word M-I-S-S. However, M-I-S-S as a word, it turns out there are 3 other I's that could go for that I. And so it doesn't change the word to put a different I in there. And so that's why we have to deal with duplicate items in a permutation. If you have too many I's, or more than one, then you could use those interchangeably and it doesn't really change the word. The same would go for, it would still be a permutation because I could write like ISSM for the word, but again, I've got repetition on the I's, and also, if you wish, on the S's. I may have used those 2 S's, but I still have those 2. And so that kind of repetition, duplicate items, changes our formula. So that's what this video is about. It's pretty simple. I'll show you an example on the next slide. So we're going to write the formula. It's on the bottom of page 618 in your textbook if you want to look. But it's a formula for permutation with duplicate items. And we're going to use the formula on the word Mississippi, figuring out how many 4-letter words we can make. So what you have to do is you want a permutation of n items, and Mississippi has 11 letters, so n equals 11. But P items are identical, Q items identical, R items identical, and so on. Then the formula is equal to n factorial over P factorial, Q factorial, R factorial, and so on. So in our case, n is 11, the number of m's is 1, the number of i's is 4, the number of p's is 2, and the number of s's is 4. And so our permutation of 4-letter words would be 11 factorial over 1 factorial times 4 factorial times 4 factorial times 2 factorial. Now you got to think about this to simplify, because it's 11 times 10 times 9 times 8, etc., 2 times 1. And on the bottom you have 1 factorial is 1 times 4, 3, 2, 1 times 4, 3, 2, 1 times 2, 1. And so you can see you can cancel the 2, 1. You could cancel the 3 at 3. You could cancel a 4 at the 4. You can't cancel the 5, so in the numerator we'd have a 5 left over. Can you cancel 6? Yes, we have a 3 and a 2. Can you cancel 7? No, so we'd have 5 times 7. Can you cancel 8? Yes, we have a 4 and a 2. The rest in the denominator are 1s, so we've canceled all the way through 8, so we have 11, 10, 9. So times 11 times 10 times 9. And this, if you multiply that out on a calculator, is the correct answer. So I hope that helps. Let me give you an example problem to do on the next window, and we'll go from there. So the last problem I want to do is a problem. In how many ways can you arrange the letters in the word Dallas? So how many ways can you arrange all the letters in the word Dallas? So pause the video and you give it a shot. So that's exactly right. Dallas has 6 letters, so 6 is equal to N. There are 2 L's, 2 A's, 1 D, and 1 S. So the way you can arrange all the letters is 6 factorial over 2 factorial, 2 factorial, 1 factorial, 1 factorial. And then you have to simplify that. 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, 2 times 1, 1 and 1 multiplied. Well, 2 times 2 is 4, everything else is a 1. So you multiply 30 times 6, and that would be 360 ways to arrange the letters in Dallas. Okay, I hope that helps. Just a note on the Mississippi word before, it wasn't 4-letter words I was making, it was arranging all the letters in Mississippi. So I caught my error doing this problem. So did any of you catch that? The problems we're going to be doing are going to be between 49 and 69. And up from 49 to 56, it'll be either odds or evens. And after that, I'll probably give you, it looks like I'm looking at like 65 is a good one, 59 is a good one, 66 is a good one. So a couple of problems like that beyond 56, but just a couple. All right, we'll talk to you later.